Nilushni, and her presentation is open for discussion.
So have you been simulating two-dimensional potential, or it's one-dimensional for your graphene? It's supposed to be two-dimensional potential, right?
Yeah.
So you were doing it with two-dimensional.
Yeah.
Okay, and then can you briefly, kind of schematically present your potential? Like you will have, how it looks like with respect to the position, like we know how the lattice of the graphene looks
just
like.
for a graphene surface. So
because this is your potential where your package is moving, right?
Yeah.
You kind of represent the potential of your graphene and then graphene oxide surface, right?
Right. So for a graphene surface, if we design the potential, it will be over here, and we can look at the wave packet dynamics moving through.
But why going down? Like what is your axis, x and y?
Oh, that's because at different voltages, when we apply a particular voltage.
But yeah, fix the voltage. So just write the potential with a fixed voltage. And you have several atoms of carbons and oxygens there, right?
Right. So basically, the idea is we have like several carbons over here, and then we design oxygen. So basically, we have oxygen here. So that's how.
Okay, so a position of oxygen increasing the value.
So
kind
this
of,
depends on the degree of oxidation. So this, because if you
just a
look
second.
at the oxidation,
What again? Your x and y?
So we'll have the change in position
Okay.
with time.
With time. Potential. So
Sorry.
potential is changing with time.
Yeah, potential.
What is y-axis here?
So
X is position and y is which letter?
What are you showing here? Potential, right?
She knows.
so we have the position over here,
Okay.
and then it changes how it changes with time.
No. You are showing something.
I thought it's not potential changes with time. It's a wave packet moving with time, right? And your Hamiltonian is changing, which of course will depends on the potential which is in your Hamiltonian. But potential by itself is not changing with time.
Let's,
It's your graphene. Okay.
please think for 10 seconds. In 7
But
seconds.
may I finish my question? You're saying this is a model, you need a potential which will represent the potential for the atoms, right?
Right.
So just atomic potential, kind of. And it looks like, so where you have an atom, you have a barrier, right?
Right.
Where you have a bond, you have going down and again. And it's going, kind of, the barrier is bigger for oxygens, in the position of oxygen, and smaller for the carbon, right?
Right.
Okay, so, and it actually has to be two-dimensional.
Yeah.
So this barrier corresponds to, when we say barrier means
The energy.
energy, right?
Yeah.
And this is your x and this is y,
Y.
if it's two-dimensional.
Right.
So she's working on two-dimensional potential or one-dimensional?
Wait. Let's answer questions one by another. So what is the question?
Well, I asked first question was like, your potential, is it two-dimensional in terms of x and y? Or you kind of represent it as a one-dimensional system, just thinking that you have a kind of, you know, a line of carbons and oxygens?
So what is the answer?
So we basically consider as one line of carbon and oxygen.
Yeah,
So
so
the
actually,
answer is, it is one-dimensional potential.
okay, so it's actually not really the surface of your graphene or graphene
Because it's
oxide.
two-dimensional.
It's not two-dimensional, it's
Yeah.
one-dimensional just because you simplify your system, right?
Right.
So then your potential now here, like each of these maximum corresponds to the position of carbon,
Right.
or
Yeah.
oxygen, so it's x, and
X
then
position.
your y-axis is
It would be the energy barrier.
the energy, yeah?
Right.
So okay, and it's not changing this time so far.
It is, well, there are no questions to me. There are only questions to speakers.
Okay, good. So
And we
now-
are 1 minute over the allocated time.
Now you introduce the voltage to your system, right? So what exactly the voltage is doing with your potential? Like how you really kind of contribute this into your, like what's the voltage really changing for your potential?
So, when we kind of, so changing the voltage means we are kind of like bring about a perturbation in the system, I would say.
Mhm.
So we kind of inject like an electron to see how it generates the electricity.
But
Or
you
the
still,
current.
your model still have just a single electron moving. Well, actually, it's a packet of whatever the electrons, right? But so when you increase the voltage, what does it mean in terms of your potential?
Okay,
Or
thank
maybe
you for
it
the
doesn't.
question. Let me reformulate it. Can you please redraw the potential after the voltage
Is
was
applied.
applied? Right now, you're showing the potential for 0 voltage.
Yeah, 0 voltage.
Yeah.
Please show the potential
25
for
or whatever it is,
non-zero.
or 25 electron volts, or whatever you were
Okay.
choosing there.
So basically it would be something like this when we apply a potential.
Yes, yes, it is the right answer.
But what is
And
the
X is position,
still
Y is
position.
potential. Okay, so your answer is that external voltage adds a slope to the overall
Yeah.
potential. Okay, let's thank the speaker.